Let's just jump right in. Like I said, kind of a quickish day today. Work through some examples because today, really all it's going to be is taking everything you learned in 6-1, 6-2, 6-3, 6-4, put it all together, and you learn a new set of operations. Okay. So like I said, today we'll be in 6-5. If I can say anything about today that's going to make it hard is because logarithms, natural logs, you've just learned them. I want you to start seeing, hopefully, through this lesson that one, you still got to remember all these little identities. That's the kind of the tough part. But it's no different than whenever you learned that whenever you saw a, say, like a to the -1, you saw that as a negative exponential, you knew you had to drop it. When that was brand new, you probably looked at that and went, what the crap is that? Why? Now you do it probably just naturally. It's just something you just do. It helps you to do things mathematically. Okay. Same thing whenever you started learning back in time, how you would, how are you doing the inverse of stuff? How did you get rid of things? Well, to add, to cancel that out, you subtract. With multiplication, you divide. Okay. That's really all that's going to happen is you're going to notice in this solving stuff, yeah, it gets a little messy. But if you look at the base underlying structure of it, you're just applying what you've learned. You're doing inverses to get variables by itself and to solve. Okay. Today you need to be very aware of the domain. Okay. We'll do those and I'll show you what I mean. So jumping right in, like I said, you can print that out. That's just literally everything we've learned about logarithms. Okay. From all the way from, how to have a logarithm, you got x is equal to a to the power of y. Well, y is equal to log a of x. Okay. And so on and so forth. We know that the inverse of a to the x, the inverse of an exponential is a logarithm. Okay. Looking at the rest of those, like I said, notice number 3, that's going to be very important. Okay. The consequence of the last point is that the log a of x is x because you're taking the inverse, right? That's how come you just end up with the x value. Remember how I always kind of said, hey, the base cancels out with what's on the inside? Well, you literally just did an inverse. That's why you get back to the x. Remember whenever we were doing compositions way early on in this class, and then I say early on, it's only been an 8-week class. Feels like it's been a while ago. But when you took a parabola and then you when you composed it with its inverse, you just get back to the original x. Because you did the inverse. It's the same thing here. Okay? And then, of course, the other things you just learned. Pluses, when you have multiplication, it turns into a plus. But the opposite holds true. If you have pluses, you can put them back as multiplication, which is nice. Okay, you'll see that very shortly. So on with the division, so on when you have x raised to an exponential, or x with an exponential, you can bring the exponential up front. Something raised to a power. So let's jump right in. I got probably about, well, let's see here. 1, 2, 3, 4. About 7 examples we'll go through. Okay. Most of them pretty easy. Hardest part on these is it's going to make you answer the question twice. Okay. So one, make sure you're utilizing your calculator. It's going to help you out a lot. Okay. Because it's going to want an exact answer. That means it's going to want, don't give me decimals. Give me the exact answer. That means keeping all the logs in it. Then it's going to say, give me the decimal answer. Okay, so let's look at the first one here. We have 8 to the power of 2x minus 4 is equal to 1898. Okay. First off, realize what we have here is we have an exponential. I want you to realize something. Now this, like I said, this is the hard part. Because this is so brand new to you, realize that you're still solving for x. To solve for x, you still got to get x by itself, which means we're not only going to have to use the properties of algebra that we know, but we're also going to have to use the properties of logarithms. Watch what I'm going to do. None of this is going to be intuitive to you day one. With enough practice, though, it'll be just as intuitive to you as if I gave you a linear equation that said solve for x. You'd be going, okay, this is what I got to do. It's just you're not used to this yet. So just follow along by example is how I'm going to do this. How I'm going to do most of these. Okay, just follow along by example. Give myself a little room here. First off, go ahead and write. I have 8, 2x minus 4 is equal to 1898. I'm gonna do everything in black. Is that okay? Is everybody, without me changing colors, kind of save us a little bit of time? Okay. Now, like I said, the goal of this, solve for x. I showed you all, for these people who just came in, just real quick, I showed you all the rules you know now. Okay, and you're gonna need them, every last one of them. We're now doing algebra. Like I said, the goal is to solve for x. If I just showed you 2x minus 4 is equal to 3x, every single one of you in here should go, I can solve for x, I can do that. If I just showed you 8 to the power of x is equal to something else, you probably be able to do that a little bit. Right now things are going to get a little bit more difficult. I promise, with enough practice, if you decide to practice this after this class, this will become just as natural to you as doing anything else that you've done before. Okay, anything. Okay, watch what I'm going to do. I've got to get the x by itself. I can't solve it in its current form. Okay, it's too hard. I can't do it. Watch what I'm going to do. I'm going to take the log of both sides. Okay. You may be saying right now, why would you do that? But watch. Remember, once I take the log, there's some properties I just taught you. Okay. Well, noticing now, look what I can do. I now have log to 8 to the power, but that means that power can go here, right? Didn't we just learn that? So now I actually have 2x minus 4 log 8 is equal to log 1898. Realize log 1898 is not log times 1898. Log 1898 is a number, right? Ugly number, it's a number nonetheless. What base do we have? 10. Base 10, okay. Watch what I'm going to do. Now, I'm going to pop this bad boy into parentheses. I'm going to distribute this. That's okay to do algebraic, right? I can say this log times something, this log times something. That's nothing weird algebraically. We've done that a lot of times. It's just the distribution. I'm going to rewrite this now as 2x log 8 minus 4 log 8. Oop, did I write? Yes. Checking here. A lot of logs. I want to make sure I'm doing everything correctly. Yes, I forgot to put the 8 right here. Equals log 1898. Okay. The goal is to get what by itself? Get x by itself. Watch what I'm about to do. Notice I have 2x log 8 minus 4 log 8 equals log, that's a lot of logs. Okay, we can almost start firing them. How about I do this? Add 4 log 8 to both sides. Don't they cancel that out on that side? Reduce out, we'll say it that way. Rewriting here, I get 2x, okay, log 8 is equal to log 1898 plus 4 log 8. Looking at it very carefully, how would I get rid of that other part? I gotta get x by itself. How could I do that? Divide by what? You're right. What else? You're on the right track. You're using algebra. I gotta get x by itself.
2 log 8.
Very good. Divide off the 2 log 8. Realize what you're seeing right now. You're seeing 2 times x times log 8. Well, to get rid of multiplication, to reduce it out, I want to divide everything else out will come in here, and I'm just gonna get rid of the 2 log 8. Do this on this side, 2 log 8. And now, what do we have? Remember, the question said this. I want 2 things from you. Express your answer both as an exact expression, okay, and a decimal approximation. The exact answer would be x is equal to log 1898 plus 4. Oops, that there. 4 log 8 divided by 2 log. Okay, that's your exact, right? The rest of it, we just go to our calculator and just put all that junk in using our fraction key, right? You would literally put log 1898 plus log 4 log 8 divided by, put down your denominator, it's gonna give you
3.81.
exactly. So our approximation, I'll put it here, 3.81. And there's your answer. Messy? Yeah. It is. I'm not gonna lie to you. Even I have to, I tell you what, every time I get back to this section, I have to go back and remind myself, okay, how am I gonna do this again? Because guess what? You don't do logs on a daily basis. It's not like something you're just running into by, you're not like going to pump gas and going, oh, forgot I had to solve for this logarithm before I got the unlimited today. You don't do it very often, okay? Even in upper math a little bit, you'll do it a little bit if they want you to show your work. But most of the time they're like, give us decimals. Okay, so you're putting a lot of stuff into a calculator. Okay. But algebraically, that's how you would do that. Okay. Let's look at another one. Look at this one. Surprisingly simple. You're gonna see. You're gonna go like, that's it. What's nice is when you start seeing something, especially E, especially with E, you're like, oh, that's it. You're gonna love it. Notice I have 2. What is E again? Natural log. Nope. No, E is not a natural log. E. What is E?
Euler's number?
Euler or Euler. People say Euler all the time. I said Euler forever. Okay, it's actually Euler because it's German or something like that. But Euler is fine with me. Okay, remember that's the one we used. Okay. Rate with the power of negative 2x minus 6 equals 52. Hey, my goal is to get what by itself? X. That's the goal. Well, let's do it. Okay. I have 2 to the e to the negative 2x minus 6 is equal to 52. Hey, how about first thing? Let's get it easy. How about we divide off by 2? Let's get rid of that guy, right? That's not weird mathematically. We've done that 1,000 times. Now, I have e to the negative 2x minus 6 is equal to, well, 52 divided by 2 is just going to give me a 26, correct? Using your intuition, how would I get rid of an e? Take the natural log of what? You're in algebra class. What you do to one side, you gotta do to the other side. So watch what happens when I take the natural log. When I do ln here, and I multiply by ln here, what is the base of an ln? It's an e. So what's gonna happen to the e on this side? All that goes away. Now you're left with negative 2x minus 6, okay, is equal to the natural log of 26. Well, isn't the goal just to get x by itself? How easy is that going to be now? Can I not just come in here and add 6? Now I've got negative 2x is equal to ln of 26 plus 6. How about we divide off by negative 2? And we'll look at that. Now I have my exact answer of x is equal to the natural log of 26 plus 6 all over -2. Okay, here's something weird, and I never could figure it out. I'm gonna tell you right now. There's two ways you could write this. And I've got to play with it, and there's probably some, I guarantee you what's happening is this. It's something very simple mathematically that's happening. Okay, very simple that I'm probably just like overlooking. Sort of like one of those things of like, don't get lost in the forest because of the trees. So I'm probably getting focused on a tree. Okay, or I'm focused on too much on all the trees. If you're not careful, you're gonna get two different answers to this one. Depends on how you write it. One, if you cheat and use a math lab, I'll tell you the answer you're gonna get. Because most people don't see it this way. Most people are gonna solve it that way and you're done, right? There's another way to write this. X is equal to -1/2. ln 26 plus 6. Okay. All I did was pull out that -2, right? When you pull out the -2, you still got to keep it in the denominator. That means there's a 1 up top for the numerator. Okay. I'm thinking, and I have to check out the math. I'm thinking this guy right here probably has to go to a negative, but I don't know. So what I did to get the correct answer, just to be honest, I did all the math to that first. But actually what I did was I did this -1/2. That gives me -0.5. And then I did the natural log, multiplied to that, and then I added 6. Because when you do it, you get this. Is equal to -0.5. And then you get 3.2581 for that natural log. Okay. And then I add 6 after that. So I end up getting 4.37. Okay, for my answer. But really, overall, how hard was it? I mean, I like the e's. When the e's pop up, I'm like, oh, natural log time. Because I like the natural logs because, man, I can get rid of them real easy because they're there. Now, logarithms are a little bit harder, obviously, because very rarely you're going to be using a base. I mean, rarely you're going to have a 10 here. Unless you're lucky. Okay, but E shows up a lot. Okay, E shows up a whole lot. This thing right here, unless you take calculus 3, that little thing right there saved me countless hours of homework. Because and nobody remembered it, me either. But we were in calculus class and the professor's like, I don't know why you are having so much trouble with this. Don't forget, take the natural log of both sides. And there was like a collective sigh. We're like, oh yeah. Because we don't do it very often. So don't feel bad, you forget this. That's why you get a note card. Everybody get a note card, by the way? Everybody's got one. Okay. Look at this one. It looks weird. Now I want to show you something real quick. Before we get started on this one, you have to remember that logarithms have a restriction, right? Okay, they have a domain. Greater than greater than 0. They cannot equal 0. Okay? They have to be greater than 0. So you have to solve and find out you have restrictions. If you're not careful, you're going to forget something you learned in this class. Okay? I know that. Because every semester I redo my notes. Every semester for this class. I won't do it for intermediate. But that says I got to kind of remind myself some stuff. And while working on your notes yesterday, I got a red bar and Hawks. And I got mad. I was like, there's no way I got mad at myself. Realized what I did. I did solve for the restrictions. I knew that. Look what I did though. When you're solving for restrictions, look what has to happen here. I have x minus 3 has to be greater than 0. But I also got another log there, don't I? I have x plus 2 has to be greater than 0. Those are both greater thans. Because I cannot say this. X has to be greater than what? 3 and -2? Does that make any sense? Because if you drew this on a number line, I'm going to have -2 here. I'm going to have 3 over here. Which one's it greater than? Can't be greater than them both, can it? No. You learn this in class. Remember, your restrictions when dealing with things like this come where they intersect. So notice, I'll do this in a different color. If this is greater than, can we all agree? This is where they intersect. So the one you would be using would be this one here. Look for the intersection. Okay, is that gonna help y'all see that now? So notice I could care less about this one here, this x plus 2. I don't care about that restriction. I care about this 3 because that's where the intersection happens. Anything that happens over here, I'm okay with. We're all right. We get any number in there, fine, whatever. Okay, but I mean, no, we can't. Okay, we can't have any number below here. If you get a number from here to here, you can't go, but my restriction says I'm allowed that. No, you're not. Because that wasn't the intersection of it. So these are the only x values you're allowed. You're allowed not 3, are you? Greater than 3. You can't even put 3 in there. It's greater than 3. Okay. So now let's do the solving. Now that hopefully that kind of helped you a little bit. So if you start getting red bars, that's your, or if you, we all do it, right? You do the math, and all of a sudden you get it wrong. So maybe you, or sometimes you're like, how do they want this? And it shows no solution. Well, how'd you get no solution? How is there no solution? That's why. Your solution falls in the restricted area. Okay, so let's solve this one. Like I said, it's not as bad as what it looks. Realize that I have what happening? Subtraction means what? Division. How about I rewrite this like division? Let me show you why this is so nice. Look what's going to happen. If I rewrite this as log 5 as division, I get x minus 3 divided by x plus 2, all equal to what? 1, right? Can I not rewrite this? I'm dealing with a log now, right? Can I just rewrite that? 5 to the power of 1 is equal to what? Can you solve that? That's solvable for you now. Notice because of those rules of logarithms, you were able to change that around. So let's finish this off. Let's go ahead and multiply both sides by. Remember, we have an equal sign, so we can get rid of fractions. Let's multiply by the least common denominator. So let's multiply both sides by x plus 2. Right? Because that's going to do what? Reduce out that x plus 2. Do not forget to get to this class, you had to pass intermediate algebra, and we did this in intermediate algebra a lot. Okay, so now you have 5 x plus 2 is equal to x minus 3. We can go ahead and just do 5x plus 10 is equal to x minus 3. Let's go and just keep solving for x. Let's subtract an x, subtract an x, subtract 10, subtract 10. I get 4x is equal to negative 13. How about we divide by 4? I get x is equal to negative 13 over 4. Am I allowed that? Notice that that's going to turn into what? 4 will go into 13 how many times evenly? 3 times, right? So doesn't that give me a negative 3 there? Well, that gives me 12. How many is remainder left? How many's left over? Yeah. How about 3.25 would be your answer? Are you allowed 3.25? No, because my numbers have to be what? Greater than what? 3. No solution. By the way, realize that this will be your exact answer there. That's your decimal answer there. I didn't go to 4 decimal places, but I think you get you can't go to 4 decimal places on that one. Okay. Are we okay with that one? I mean, are you okay with the restriction part? You understanding why a little bit? Okay. Look for the intersection of them, okay? Let's do probably the messier. I found there's a few messy ones, but I found one of the messier problems that you're going to be doing. It is this one right here. I'm gonna give myself a little more room. I write a lot bigger on this screen than I do at home on my screen. So notice we have, once again, we have solved this guy right here. Give an exact and give a decimal. Okay. Go with me carefully on this one. I'm going to start working it out step by step. No skipping of steps. Have you found that out in Hawkshead that they skip a lot of steps? Yeah, they expect you to just remember. Oh, remember 6.1? You remember this? No, I just learned 6.1 4 days ago. I do not remember anything from 6.1 right now. They just assume that you know. So I'm making sure to add back in some of the steps for you. Okay. First off, we see an E. I like E because E means if I want to get rid of it, I'm immediately going to do what? Where?
Both sides.
Both sides. So how about on our first step? Let me go ahead and just rewrite that. And with I'm multiplying a natural log on both sides, that's going to immediately remove that E. Okay. So I have ln E 3x plus 14 is equal to, well, once again, I've got this ln 146 4x plus 11. Knowing what we know now, let's go ahead and realize, remember you have a base E there. That reduces all of that out, just leaving that 3x plus 14, right? If you really want to know why it's leaving that, okay, remember what can I do with this? I can move him out front, right? And therefore, just the e's are going to be inverses of each other. And so therefore, it's going to go to a 1 and we're good. I'm just not doing that step. Okay, just so you kind of realize that. So rewriting this, I'm going to have 3x plus 14 is equal to, well, what did I just say I could do with exponents? Put them out front. Why don't in the solving process, I go ahead and do that? Because we're going to need to. Can we all agree that that's probably going to be something that's going to need to happen? Well, look, I've got 4x plus 11. And then I have the natural log. And I'd go ahead and put a parenthesis around that. So you don't, first off, natural log written down can look a lot like a 1. Good so far. I don't want to go too fast. Okay, so review. E, got it. It's in there. I'm going to do what to both sides? Take the natural log. That is going to reduce out that E. Because remember, E is not a variable. Okay, I get it. The whole time in math, you're like, well, those are variables. No, E is not a variable for you anymore. Just like most of the time in a math book, if you see K, K is not a variable. M is not a variable for you anymore in a good math book. Remember, M is slope. K is a constant. E is a number. Pi is not a variable. So we have to be able to reduce it out. We just did that. Now using our powers that we've learned of logarithms and natural logs, I can take that exponent, move it toward the front. Now going back in time, let's use the distributive property. How about I come in here and distribute that natural log into there? Okay. Right again. 3x plus 14 is equal to, I've got 4x natural log of 146 plus 11. I will definitely be using a parenthesis around the 11. Natural log of 146. My goal is to get what by itself? Okay, just hear me out. I need to get the x's on one side. Is that any different than what we've done algebraically anytime in this class ever? Get the constants, get them to one side. So let's do that real quick. I have an x right here that's tied in with all that, right? That's 4x times the natural log of 146. Let's get it to the other side. So since I have a plus, let's go ahead and subtract it. So let's subtract 4x ln 146 from both sides. That cancels it out on that side. Don't just be monkey see, monkey do. Understand why I'm doing what I'm doing. So that way you can do it later on your homework, on your chapter test, and on your assessment. Oh, sorry, on your final. X is the one side. Rewrite. 3x minus 14 minus 4x. I'm going to put a little parenthesis there. ln 146. You don't really need the parenthesis around the 146, I mean the 4x. All equal to, well, what's left on the other side? I'm still left with the 11 ln 146. I've got a constant on my left-hand side. If I was solving this at any other time, what would I do as a constant?
Yeah.
Add it to where?
The other side of it.
Exactly. Add it to both sides. So I do a plus 14 on both sides. That cancels it out on that side. Okay? Let's come back up here. Now watch what's going to happen. I have 3x. That is 3 times x minus 4 times x times the natural log of 146. I'm saying that so hopefully you kind of catch on to what I'm about to do here. Equals 11 natural log of 146 plus 14. Watch what I'm about to do. I've got to get that x by itself. What rule says I can't do? Let me put a big parenthesis here and a big parenthesis here. Can I not factor out my GCF? What's my GCF? Is that not a common factor amongst both those? That is 3 times x, 4 times x times the natural log of 146. So x is a common factor. So I'm going to pull out the x, and that leaves me with 3 minus 4 ln 146 is equal to 11 ln 146 plus 14. Hey, I have x times all that junk. What do you think I'm going to do to all that? I got to get x by itself. What am I going to do?
Right.
Yeah. Divide by what? Hey, divide by everything. Let's get rid of this whole junk. What we do to one side, we got to do to the other. And if you will be glad to know, look at what you just did. X is now, x is equal to what? Well, it's equal to 11 natural log of 146 plus 14, all divided by 3 minus 4 ln 146, which can be put in your calculator very easily using your little fraction key. But when you do that, you're going to get 2.41. And there you go.
And you don't do the subtraction on the 3 and the 4 because the 4 is connected with the natural log.
Exactly. That's 4 times. Yeah. And the 3 is just there.
Mhm.
But once you got it out, it's just kind of left over. And so you're like, I'm going to divide all that whole junk. Okay. You get the 2.41. Didn't check it out. So really just in depth, right? It's just a slow process. And if you're honest with yourself right now, I know I'm saying this is easy. It's not. It's not easy at all. You're not used to this at all. But really, if you think about it, did we do anything weird mathematically? Not really. I said, hey, I've got this over here. I need to get this to the other side. The whole goal is to do what? Get X by itself. That's the goal at the end of the day. Okay? They want your exact answer. They want the rounded answer. Good? Here's this one. Looks kind of ugly, doesn't it? Like already, ugh. First off, you're dealing with logs, okay? Logarithms have what?
Restrictions.
Restrictions, okay? Why did I not worry about a restriction up here?
You didn't have a log?
Right. Exponentials, their domain is all real numbers. Okay? So you don't have to worry about a restriction there. Their domain is all real numbers. That's how come if you kind of go back in time, I said to you, and I said these words a lot. Please get good at your domains. Please, I said this in intermediate. Please get good at them. That's how come they were on every assessment I gave you. I said, you're going to need them later on. They're going to come in helpful. Welcome to that. Knowing your domain, knowing is when am I going to have a restriction? Well, when the domain is restricted, you're going to have a restriction. You got to know. If the domain's all real numbers, you're like, I don't care. I get any answer I want. Okay. Here, once again, you have restrictions, or you have a restriction, because remember, I can come in here and go, okay, I've got x plus 2, I've got x minus 2, and then I've got x minus 3. All of these have to be greater than 0. Am I right? And then notice I get what? X greater than, x can be greater than -2, 2, and 3. Well, let's be honest. If I drew all of this on a number line, well, -2 is here, 2 is here, 3 is there. Realize I have this happening. Where is my restriction? Does it start at -2? Where's it going to start? Yeah, exactly. Look at this. If I come here, that's the restriction from -2 over. If I come here, there's the restriction for that. That'd be the intersection. But if I go one more, that's the intersection of all of them. And so that's where my restriction is going to begin. Okay, that's the one I'm looking for right there. So when I'm solving, x has to be greater than what? 3. To help y'all see it more with the colors, kind of like seeing how they all kind of like, your restriction starts where every single one of them overlap. That's the intersection of all those graphs, or of all that on that number line. And now we solve. I have the same basis, which means I have a plus sign, which means I can do what? Multiply. So can I not rewrite the left-hand side as this? X plus 2 times x minus 2. Don't forget your log base 5. Is all equal to log 5 x minus 3. Are you good with that? Okay. Going with another rule to make this look a little bit easier, how about I realize that I can rewrite this again? Notice I have 5 to that, so that's going to be 5 with the exponential log 5 x minus 3 is all equal to, hey, x plus 2 x minus 2. Anybody see anything weird? Get the red. I hate this green color somebody's using. Do you not see an inverse? So what's about to happen? Doesn't all of that just go away now? And then you're left with what? Oh, well, this is nice. I'm literally just left with x minus 3 is all equal to, oh, x plus 2, x minus 2. Oh, that's kind of nice. And now we're back in basically intermediate algebra or chapter 1 of this class. Okay, let's kind of come in here and finish this up. Let's go ahead and realize, hey, what is this? Don't lose it. What do you see on the right hand side?
A difference of squares.
A difference of squares. I don't have to do any foiling. I can rewrite that as a difference of squares right now. I come here and go, doesn't that just turn into x squared minus 4? If you didn't see it, can you foil it and find it anyway? Exactly. Okay, so don't freak out. So notice now, since I'm dealing with a quadratic, I'm going to go ahead and do what?
Equal it to 0.
Thank you very much. So let's go ahead and add 3 to both sides. And let's go ahead and subtract x from both sides. And then let's rewrite this up here as x squared minus x minus 1. All equals 0. Well, you got to solve it, don't you? And there's a problem with that one. I don't see how you're going to factor that. I can't think of any factors that will multiply to 1 and add to 1. Do you? So what do we do?
Quadratic formula.
There you go. We thought I was gonna have you use the quadratic formula at least one more time in this class before we left. Come on, we've got an A, we got a B, and we got a C. So we can rewrite this as, remember your quadratic formula is negative B plus or minus B squared minus 4AC, take the square root of it, divide by 2A. X equals. Kind of looks like that's probably going to be the exact form, isn't it? But you're going to have to be careful. I'll show you why. Let's go and start putting everything in. Notice my coefficient for B is going to be a 1. So that's going to give me a negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times negative 1. All times 2 times 1 is just going to be 2. I'm going to give it to you. When you do all the math on the inside, your discriminant, that's just going to turn into a 5. Okay? So I want you to be very careful. Your answer is not this for your exact. It is not x equals 1 plus or minus the square root of 5 divided by 2. There's a reason you've got 2 answers. Am I right? You're going to have 2 decimals. Well, let me show you something here. Guess what? Now, the exact answer, they might let you have this for an exact. I'm going to be honest, maybe. But here's the problem. When you start solving this, realize you get 2 answers. You get 1 plus the square root of 5 divided by 2, and then 1 minus the square root of 5 divided by 2. You're going to get 1.6 and negative 0.6. What's the problem with those?
Restriction.
Yeah. None of them work. So right here, you have no solution once again. You all right with that one? Getting a little bit easier. I mean, just a little bit. You're like, okay, I can kind of see it a little bit better. Last 2 questions. You have 2 word problems on your homework. We're working real fast, so we kind of know how to work. You don't have to spend all weekend long trying to do this because you only have till Sunday. Okay. Notice how long does it take for 1,625 to double if invested at 5%, compounded continuously. Okay. Round your answer to 2 decimal places if necessary. Well, let's remember that we have a formula here. A is equal to our principal and then rate time with Euler's number built in for continuous compounding. realize they are giving me some very valuable information here. They say, how long does it take to double? Okay, that's 1625. That's my amount. Okay, well, we know that my A is going to be 2 times 1625, which is going to give me 3,250. They also give me my principal, which is 1625. Am I right? That's the amount of money I'm investing. I'm trying to see the A, how long it takes to double. And they also give me a rate of 5%. So 0.05. Do make sure that you are changing that decimal around. So let's write this out. What do we have? Let's put everything we know into the formula, and notice that we have 3,250 should equal, well, I've got this 1625 E to the what? Well, I have my R, which is going to be 0.05. I do not have the T though. Remember, we're saying how long will it take to double my money? So the T is unknown. Do not jump right in and go, well, can I just go ahead and take the natural log? I cannot yet, can I? There's something in front of that natural log I need to get rid of first, okay? Which is going to be what? 1625. 1625, 3250 divided by 1625 is going to get you back to 1625 because you only doubled it. So you get 1625 is equal to E 0.05 T. Hey, what do you think I'm going to do now? Let's take the natural log of both sides. So how about I take a ln here, and I'll take the ln here. And what's nice, what happens to the E on the other side? It's gone now, isn't it? Okay, so I have ln of 1625 is equal to, well, look, 0.05 T. How about I just divide off 0.05? And that gives me T is equal to, I have no idea, let me get my calculator. Doing the math very quickly in my calculator, I get ln of 1625, don't forget to close your parenthesis, divided by 0.05, and yeah.
The double? That investment, buddy.
Oh, you know what I did wrong here? Let me see it. Should put a 2 there, didn't I? Two. I got hooked up on my LNs. Right? So what should I have here now? Take the ln of 2. I knew it wasn't gonna be 147 years. I was like, I've invested money and it didn't take no 147 years. Okay, so now do it. You got the ln of 2. So good catch. Do things too fast, you make what kind of mistakes? Good. What kind of simple mistakes, right? Okay.
Why is it?
But simple, but think about it. Use your intuition. I did the math to that right now. I didn't have it wrote down. I was like, that doesn't right. My brain automatically went, it shouldn't be 147. Could it? Now it could. But I said, how long is it going to take for this to just shoot to some astronomically large number? Okay. Use your intuition. You should start having it now to where sometimes when you get an answer, have you ever had it and you felt uneasy about the answer? Sometimes it may just be like, I hope this is the right answer. But it also may be like, this doesn't sound right. especially on application problems. Like that sounded fishy. And I did some bad math because I said, hey, you know what? I did that 3250 divided by 1625. And then what I do? I just wrote down 1625 again. Wasn't paying attention, took the ln, did the correct math after that, took the ln of both sides. I should have been taking the ln of 2, not the ln of the 1625. Okay, so notice when you do this, it should double in 13.86 years. You good on that one? So don't make the same mistake. You're better than me. All right. Last one. More simple than what it looks actually, believe it or not. Okay. The magnitude of an earthquake is measured on the Richter scale as a logarithm of the intensity of the shock wave. For a magnitude R and intensity I, the formula is R is equal to log I. Okay. The March 30th, 2002 earthquake in Mesa Grande, California measured 3.8 on the Richter scale. In Calexico, the Calexico earthquake on March 22nd, 2022, March 22nd, 2002, measured 2.6 on the scale. How many more times more intense was the Mesa Grande, California earthquake than the Calexico earthquake? Round your answer. Okay, first off, realize what they're asking us for. They asked us for the intensity. Okay, we don't have intensity, do we? It doesn't give it to us. That's okay. They give us a formula. So for the Mesa Grande, I'm just going to try to abbreviate that. Notice we're going to be using the formula log I for this one is equal to what? Does it right up here? 3.8. What's my base? 10. Exactly. So realize I actually have 10.38 is equal to I. Oh, look, I just found my intensity. By rewriting the whole thing, I just found my intensity. Well, let's do the same thing. Over here in Calexico, I'll put it as a C. I have, once again, a log I. But what is its intensity?
2.6.
Very good, 2.6. Solving, knowing how, because I can change that logarithm back into an exponential. That's what they are there. We can write it back in its original form. I can say, hey, doesn't this change into 10? 2.6 is equal to I. And now I have two intensities that I can say, hey, the intensity of this shock wave was 10 to the 3/8 power. This one over here was 10 to the 2.6. To find out how much something is stronger than something else, what kind of math do we use? You're thinking of lengths. Look at how it reads it. It says multiplication, so if I want to find out how much wrong.
Division.
Division. If you want to find out how much something is times something else, think about it. If I have 10 divided by, or 10 and 5, how much larger is the 10 compared to the 5? Isn't it 2 times larger? Well, how do you find that out? 10 divided by 5 is 2. Okay. So if I do the math of this, I got the Mesa Grande, and then I've got the Calexico, and then I put 10 to the 3.8 divided by 10 to the 2.6, which if you want to be mathematical all the way around, you can say 10 to the 1.2 is going to equal, it is how much times larger? How about 15.85 times more intense?